Hello everyone. Today we discuss the topic about network layer. Network layer is responsible for transferring the data packet from one device to another device across the different network. It operates at the third layer of the OSI model. It uses a network layer uses the IP address to find the best path from the source to destination. It ensures the efficient and reliable data transmission across the different network, and also it establishes the secure communication. Functions of network layers are routing, logical addressing, internetworking, and fragmentation. Routing determines the best path for the data packets to travel from the source to destination. Next one is the logical addressing. The network layer assigns the unique addresses to the device on your network. These addresses help to identify the source and the destination of the data packet. Next one is the fragmentation. It split the large data packets into the smaller fragments for transmission. IP stands for Internet Protocol, a set of rules that governs how the data packets are created and transmitted across the network. IP address is a unique identifier assigned to a device in a network, enabling the communication between them. Here, the IP addresses are essential for identifying the devices and locating them within a network. IPv4 Internet Protocol version 4 addresses are 32-bit long. It gives you 2 power 32 possible unique addresses. Next one is the Internet Protocol version 6. IPv6 addresses are 128-bit long. It gives you 2 power 128 possible addresses. Logical addresses is necessary because it enables the universal communication. It identifies every single host on the internet, so a data packet can be delivered from one host to the another host. All the IPv4 addresses are 32-bit long. It is equivalent to the 4-byte. The address encodes the both network number and the host number. IP addresses consist of two components. One is the network ID, another one is the host ID. Network ID is used to identify which network a device belongs to, and the host ID identify with a specific device within that network. IP addresses IPv4 uses the two types of notation. One is the binary notation, another one is the dotted decimal notation. Binary notation as 32-bit address, it equivalent to the 4 bytes. It written as raw binary or raw binary data, like zeros and ones. Next one is the dotted decimal notation. The internet addresses are usually written in decimal form with a decimal point separating the bytes, called as dotted decimal notation. IPv4 splits into the 5 category: Class A, Class B, Class C, Class D, and Class E. Class A address IPv4 addresses can have the three field. One is the class type, another one is the network ID, third one is the host ID. Class A addresses were designed for the large organization. Here the first bit as fixed as 0, remaining 7 bits are used for net ID. All other 24 bits used for the host ID. It gives 128 possible networks. So next one is the Class B address. Class B addresses were designed for mid-size organization. The first two bits are fixed as 10. Remaining 14 bits used for the network ID. 2 bytes are used for host ID. So here in class B addresses gives 16,384 possible networks. So next one is the class C. Class C addresses are used for a smaller organization with a limited number of hosts. Here the first 3 bits are fixed as 110. 3 bytes goes to the network ID and the remaining 1 byte go to the host ID. Over 2 million possible networks can be created in class C address. Next one is the class D address. It is used for the multicasting purpose. In class D, first 4 bits are fixed as 1110. Remaining 28 bit used for the multicasting purpose. So it means when one sender needs to broadcast the same data to a group of receivers simultaneously. Next one is the class E. Class E is used for reserved purpose. The first 4 bits are fixed as 1111. The actual usage was never formally defined. Most of the network system just discarded as illegal or undefined. Thank you.